7.4 goes over solving polynomial equations in factored form. So you're just solving equations of expressions that are factored for you. So if you look here, factored form is literally taken from standard form. So if you look to see that we have a couple examples of the difference between standard form and factored form, your standard form would be in the form of x squared plus 2x or x squared plus 5x minus 24. If that x squared plus 2x was factored, it would just be x times x plus 2. If the x squared plus 5x minus 24 was factored, it would be x minus 3 times x plus 8. You're going to be using your zero product property in order to solve all of these equations, which just means if it's in factored form, you set each part equal to 0 and solve for the variable. With these, if you look at example 1a, we are given 2x times x minus 4 is equal to 0. Again, this is factored for us, so we can just take the 2x, set it equal to 0. We can take the x minus 4 and set it equal to 0. So we now just have two equations that we're solving for. When we divide each side by the 2, we get that x is equal to 0. When we add the 4 to both sides, we get that x is equal to 4. So our two solutions for this is that x is equal to 0 and that x is equal to 4. For example B, we have x minus 3 times x minus 9 is equal to 0. So again, we're just going to set each part equal to 0. So x minus 3 is equal to 0, as well as x minus 9 is equal to 0. In order to solve the x minus 3 is equal to 0, we're going to add the 3 to both sides, and we get that x is equal to 3. In order to solve the x minus 9 is equal to 0, we add 9 to both sides, and we get that x is equal to 9. So you have two solutions here. Once again, x is equal to 3, x is equal to 9. For example C, we have x times x minus 1 is equal to 0. So that x is set equal to 0, and that x minus 1 gets set equal to 0. So from here, we're just going to solve the x minus 1 is equal to 0, and we add the 1 to both sides to get that x is equal to 1. Now, with that x is equal to 0, you don't need to do anything with it because it's already solved for x. So again, you have two solutions here, one that's x is equal to 0, the other that x is equal to 1. For example D, we have 3t times t plus 2 is equal to 0. So we're going to set the 3t equal to 0, and we set t plus 2 equal to 0. For the 3t is equal to 0, we're going to divide each side by 3 to get t by itself, and t is equal to 0. For the t plus 2 is equal to 0, we're going to subtract 2 from each side, and we get that t is equal to negative 2. So again, two solutions, t is equal to 0, t is equal to negative 2. For example E, we're given z minus 4 times z minus 6 is equal to 0. So we're going to set that z minus 4 equal to 0, as well as that z minus 6 is equal to 0. For z minus 4 is equal to 0, we just add the 4 to each side, and we get that z is equal to 4. For z minus 6 is equal to 0, we add the 6 to both sides, and we get that z is equal to 6. For example F, we have 3x plus 2 times x minus 4 is equal to 0. So the 3x plus 2 gets set equal to 0, and the x minus 4 is equal to 0. For the 3x plus 2 is equal to 0, we're going to subtract 2 from each side. We're left with 3x is equal to negative 2. From there, we're going to divide each side by that 3 to get x by itself. So x is equal to negative 2 over 3. For the x minus 4 is equal to 0, we just add the 4 to each side, and we get that x is equal to 4. So again, two solutions, x is equal to negative 2, and x is equal to 4. With our next section, we're working with repeated roots. So with these, you're going to be looking at a perfect square trinomial factored out for you, or even the difference of squares factored out for you. With this, for example, 2a, we have something like 2x plus 7 times 2x minus 7 is equal to 0. This is factored for you, and the two sets of parentheses are different because the sign between the 2x and the 7 are different in each. So with ones like this, you're going to have to separate this and do both of them to where they're equal to 0. So 2x plus 7 is equal to 0, and 2x minus 7 is equal to 0. We're going to subtract 7 from each side with the 2x plus 7 is equal to 0, and we get 2x is equal to negative 7. Then we just divide each side by the 2 to get that x is negative 7 over 2. For the 2x minus 7 is equal to 0, we're going to add 7 to both sides. We get 2x is equal to 7. And then we divide each side by the 2, and we get that x is equal to a positive 7 over 2. Now you can leave these two separate like this and just give that x is equal to negative 7 over 2 as well as x is equal to 7 over 2. Or you can rewrite it to where x is equal to plus or minus 7 over 2. When you do it this way, it's just representing that you have the positive of 7 over 2, that's an answer, as well as a negative 7 over 2, that's an answer. With example B, we have x minus 1 squared is equal to 0. So you could do this one two ways as well. You can either do x minus 1 squared is equal to 0 and start by taking the square root of each side, or you can separate it to be x minus 1 times x minus 1 is equal to 0. Again, totally up to you. I'm going to do this both ways so that way you see each of them being done. The first way that we're going to do this is separating it into x minus 1 times x minus 1 is equal to 0. So this becomes x minus 1 is equal to 0, as well as x minus 1 is equal to 0. These are the same exact thing. So do you have to solve them twice? No, you can just solve it once because you know the answer is going to be the same for both. So with this, we're going to add the 1 to both sides, and we get that x is equal to 1. If you did it to where you took the square root of both sides, you would take the square root of both sides. When you're doing this with an equation and you take the square root of both sides, whatever you have that you're finding, where like the opposite of the one that cancels out the power, you're going to have a plus or minus with it. That's automatic. If you take the square root of both sides, the number that's underneath the radical that does not have the exponent on it gets the plus or minus. Okay? So with that, 0 is neither positive nor negative, so we can just rewrite it as x minus 1 is equal to 0. Then add the 1 to both sides, and we get that x is equal to 1. So same answer, just a different way of doing it. For example, C, we have x plus 1 times x minus 3 times x minus 2 is equal to 0. For this one, we're going to set the x plus 1 equal to 0, the x minus 3 is equal to 0, and the x minus 2 is equal to 0. From here, for the x plus 1 is equal to 0, we subtract the 1 from each side, and we get that x is equal to negative 1. For the x minus 3 is equal to 0, we're going to add the 3 to both sides, and we get that x is equal to 3. For the x minus 2 is equal to 0, we add the 2 to both sides, and we get that x is equal to 2. So we have x is equal to negative 1, x is equal to 3, and x is equal to 2. For example D, we have 3x plus 5 times 5x plus 8 is equal to 0. So we're going to separate this and do 3x plus 5 is equal to 0, as well as 5x plus 8 is equal to 0. For the 3x plus 5 is equal to 0, we're going to subtract the 5 from each side. We have 3x is equal to negative 5. Then we just divide each side by the 3, and we get that x is equal to negative 5 over 3. For the 5x plus 8 is equal to 0. We're going to subtract the 8 from each side. We get 5x is equal to negative 8. Then we divide each side by the 5, and we get that x is equal to negative 8 over 5. So x is equal to negative 5 over 3, and x is equal to negative 8 over 5 are our solutions. For example E, we're given b plus 7 squared is equal to 0. So again, we can take this and just take the square root of both sides and get b plus 7 is equal to 0. We solve for b. Or we can separate it into b plus 7 times b plus 7 is equal to 0. I'm going to take the square root of both sides just because I find it easier. I know that 0 is neither positive nor negative, so this is just going to give me b plus 7 is equal to 0. From here, we can subtract the 7 from each side, and we have b is equal to negative 7. For example F, we have d minus 2 times d plus 6 times d plus 8 is equal to 0. So we're going to separate this. We're going to have d minus 2 is equal to 0, d plus 6 is equal to 0, and d plus 8 is equal to 0. The d minus 2 is equal to 0. We add 2 to both sides. We get d is equal to 2. The d plus 6 is equal to 0. We're going to subtract 6 from each side, and we get d is equal to negative 6. For d plus 8 is equal to 0, we subtract 8 from each side, and we get that d is equal to negative 8. So we have d is equal to 2, d is equal to negative 6, and d is equal to negative 8. The next part of this lesson goes over finding the greatest common monomial factor. So we're factoring out the greatest common factor between these terms that were given within each expression. For example, A, it tells us 4x squared, or 4x to the 4th power plus 24x cubed. With this, we are going to divide out the greatest common factor between each of these terms. Between the 4 and the 24, they're both divisible by 4, so we're going to factor out a 4. Between the x to the 4th and the x cubed, you want to keep the variable that is the same with the lowest power. So they both have an x. The lowest power is the cubed, so we're going to factor out x cubed. So this 4x cubed is factoring out. It goes out front. Whatever's left over goes in parentheses. So the 4x to the 4th power, the only thing you have left is x, because 4 divided by 4 is 1. X to the 4th divided by x cubed is x. So the only thing it is 1x, which is x. And then the 24 divided by 4 is a positive 6. X cubed divided by x cubed is 1. So it's just 4x cubed times x plus 6. For example B, we have 8y squared minus 24y. So when we look at both of these, 8 and 24, their greatest common factor is 8. Both of these terms have a y attached to them. So the lowest factor, or the lowest exponent here is 1, so it's just going to be a y that we factor out. So that 8y is factoring out. It goes out front. 8 divided by 8 is 1. Y squared divided by y is y. The negative 24 divided by 8 gives us negative 3. And y divided by y is 1, so negative 3 times 1 is just negative 3. So 8y times y minus 3 is our answer for that one. Example C gives us 8x squared y cubed minus 4xy squared. So with this one, you have 8 and negative 4. Their greatest common factor is 4. Then x squared and x. So x and x cubed and y squared, so y squared. So we're factoring out the 4xy squared. The 8 divided by 4 gives us 2. X squared divided by x is x. Y cubed divided by y squared is y. For the negative 4 divided by 4, that gives us a negative 1. X divided by x is 1. Y squared divided by y squared is 1. So it's just 4x squared, 4xy squared times 2xy minus 1. For example D, we have 3x squared plus 12xy minus 6y squared. So all of these are divisible by 3. If you look, the first term and the second term have an x on them, but the third does not. So you cannot factor an x because not all the terms have an x. The last and the middle term have a y attached to them, but the first does not. So you cannot factor a y out either. So the only thing you can factor out from here is a 3. So we're going to have x squared plus 4xy minus 2y squared left over. So that gives us 3 times x squared plus 4xy minus 2y squared. So when we look at example 4, we're solving each equation, but we have to factor out the greatest common factor first. That is when you're factoring, the first thing you want to ask yourself every single time. Is there a greatest common factor that I can factor out? If there is, that has to be done first. So if we look at example 4a, we have 2x squared plus 8x is equal to 0. Both of these terms are divisible by a greatest common factor. That greatest common factor is 2x. They both are divisible by 2. They both have an x in them. The smallest power is 1, so that's why it's 2x. From here, that 2x is factoring out, so that's going to go out front of parentheses. What's left over will go inside the parentheses. So 2x squared divided by 2x is x. 8x divided by 2x is 4. So we have 2x times x plus 4 is equal to 0. From here, since we're all factored out, we can set each part equal to 0 and solve. So we have 2x is equal to 0 and x plus 4 is equal to 0. For the 2x is equal to 0, we divide each side by 2 and get that x is equal to 0. For the x plus 4 is equal to 0, we're going to subtract 4 from each side, and we get that x is equal to negative 4. So again, 2 answers, x is equal to 0, x is equal to negative 4. For example B, we have 6n squared is equal to 15n. We're going to start this one by getting all of our terms on the same side. So we're going to subtract the 15n from each side. This is going to give us 6n squared minus 15n is equal to 0. From here, that 6n squared and that 15n are both divisible by 3n, so we're going to factor out the 3n. So 3n times whatever's left over is equal to 0. The 6n squared divided by 3n is 2n, and negative 15n divided by 3n is negative 5. So 3n times 2n minus 5 is equal to 0. We're going to set that 3n equal to 0, and that 2n minus 5 is equal to 0. The 3n is equal to 0. We're going to divide each side by the 3. We get that n is equal to 0. For the 2n minus 5 is equal to 0, we're going to add 5 to each side. We get 2n is equal to 5. Then we're going to divide each side by the 2, and we get that n is equal to 5 over 2. So our two solutions here are n is equal to 5 over 2 and n is equal to 0. For example C, we have a squared plus 5a is equal to 0. So with this one, we're going to factor out the greatest common factor, which is just a. So this gives us a times a plus 5 is equal to 0. We're going to set each part equal to 0, so it's going to give us a is equal to 0, and a plus 5 is equal to 0. We subtract each side with that 5 and get that a is equal to negative 5, and a is equal to 0. For example D, we have 3x squared minus 9x is equal to 0. Both of our terms are on the same side, so we're going to factor out the greatest common factor. It's going to be 3x. So we have 3x times x minus 3 is equal to 0. That 3x gets set equal to 0. That x minus 3 gets set equal to 0. For the 3x is equal to 0, we're going to divide each side by the 3. We get that x is equal to 0. For the x minus 3 is equal to 0, we're going to add the 3 to both sides. So we get that x is equal to 3. For example, E, we have 4x squared is equal to 2x. For this one, we're going to have to move the 2x over, so we're going to subtract it from each side. We get 4x squared minus 2x is equal to 0. Our greatest common factor between these two terms is 2x, so we'll factor that out. We get 2x times x minus 1, 2x times 2x minus 1 is equal to 0. From here, we're going to set each part equal to 0, so 2x is equal to 0, and 2x minus 1 is equal to 0. And we're going to solve both of these. For the 2x is equal to 0, we're dividing by 2 on each side, so x is equal to 0. For the 2x minus 1 is equal to 0, we add the 1 to both sides, and we get 2x is equal to 1. From here, we're just dividing each side by 2, so we get that x is equal to 1/2 as well. For example F, we have 6x is equal to 18x squared. Now with this one, I'm going to move my 6x over because my 18x squared is already positive and I want to keep it positive. So I'm going to subtract the 6x from each side. I have 0 is equal to 18x squared minus 6x. Now I can also write it in this form where 0 comes last. It's totally up to you. From here, my greatest common factor between these two terms is 6x. So I factor that out, and we have 6x times 3x minus 1 is equal to 0. We're going to set the 6x equal to 0. We're going to set the 3x minus 1 equal to 0. We're going to solve for both of these. For the 6x is equal to 0, divide each side by 6, and you get that x is equal to 0. For the 3x minus 1 is equal to 0, add the 1 to both sides. You get 3x is equal to 1. Then divide each side by the 3, and you get that x is equal to 1/3 as well.